In this video, I'm going to demonstrate how to carry out a one-way analysis of variance with repeated measures on our data set here, where we have 10 research participants, each measured on a measure of performance while riding a bike at 3, 6, 9, 12, and 15 minutes while riding that bike. And each measure indicates the degree of unsteadiness, or what we might classify as wobbles, as the cyclist becomes more fatigued from 3, 6, 9 up to 15 minutes, and the number of wobbles or mistakes of unsteadiness increases generally for all 10 participants. Now, with the one-way ANOVA, we want to evaluate if there is a statistically significant difference within these time points. And to run that analysis here with Excel, I'm going to go up to the menu item, and I'm going to click Data. I'm going to go all the way to the right, and I'm going to click Data Analysis. I want to open up that toolbox, and we see a lot of options here. What I want here is what's called ANOVA two-factor without replication. That doesn't sound intuitive here because we have each of the 10 participants measured 5 different times, but in Excel this is the option that we want when we have a one-way ANOVA with repeated measures. So I'm going to click OK, and then another box is going to open up where I have to input the necessary information in order to ask Excel to do the calculations necessary. So I'm going to click Labels here because I'm going to copy over the labels that I have in my spreadsheet. I'm going to go up to the input range bar, and I'm just going to click on that once, and I'm going to make that active. Then I'm going to go over to my spreadsheet, and I'm just going to highlight with my mouse the headings and the data, including the participant numbers here. By default, Excel will set the type 1 error rate, or the alpha level, at 0.05. If there's any interest or intention to using a different alpha level, this is where the researcher or the user would type that in, but I'm going to leave that at 0.05. Now, in terms of the output for our data, I'm going to put this into a new worksheet. We could specify the output range on the same worksheet, but I'm going to put it in a new worksheet, and that'll open up a new tab at the bottom. So now that I'm ready, I'm going to go ahead and hit OK. And here we have our new worksheet, and with our worksheet here, we have at first a summary of all of the data. And so the first batch of data here are the summary statistics for each of the participants here. So here we have participant 1 that has 5 measurements, participant 2, 3, 4, 5, so on and so forth. What we're really interested in is the second batch of data, where we have the descriptive data at minute 3, minute 6, 9, 12, and 15, and the overall ANOVA approach is to examine if there is a statistically significant difference within any one of these and between these different time points. And so the first step here is that Excel makes it very handy in that it generates the average and the variance for each of these levels. To get the standard deviation, I would just compute the square root of the variance values. So I'm going to scroll down here, and I'm just going to expand that view. And what we see here is our ANOVA table. I'm just going to expand this so we can see and read our headings here. So Excel will automatically put rows, columns, and the error. So the rows source of variation is the variation due to the participants. The one that goes to our research question, if there's a significant difference across the 5 time points, that would be our column source of variation. And the statistics to report in this case would be the calculated F value for the columns. That's the one we want, and that tells us that the actual F value from the data exceeds the critical value that is established at 2.63 if we have an alpha level of 0.05. But we see our actual F statistic from the data is much greater than that than the critical value, and so our actual type 1 error rate from the data is considerably less than 0.05. In fact, it's 2.7 times 10 to the negative 8. And so we would move the decimal place to the left 8 times, and that indicates that there is a statistically significant difference between these time points. And so at this point, we would have to do a post hoc procedure where we run a series of pairwise comparisons to examine where those specific differences exist. And we'll do that on the next video.